I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. We are starting to look at the world of edge computing, and so we've convened a panel here to discuss the key concept. What is edge, really? Before we begin our conversation, though, let's meet who's on the panel.
I'm Koroush Saraf. I'm the VP of Products and Marketing at ZPE Systems.
Hey y'all, I'm Gina Rosenthal. I am the founder of Digital Sunshine Solutions.
Hi, I'm Scott Loughmiller, Chief Product Officer for Scale Computing.
And I'm Roy Chua, the principal and founder of EverThink, an analyst firm.
So we're going to be talking about Edge at our Edge Field Day event, and this is something we've been covering at Gestalt IT and at many other places as well. But I think that before we get into sort of what is Edge, I think we need to maybe talk about why is Edge? Why is Edge a thing? Why is there really some difference between cloud, data center, Edge? And then we can kind of dive into what it exactly means and how you build it and so on. So first off, what is the driving factor behind Edge? Koroush?
So from my point of view, the ability to run certain workloads that are close to the users and things because of various challenges of bandwidth or physicality in terms of jurisdiction, those are essentially the problems that IT admins need to be solving. So the wish is to have that cloud experience that makes life easy, but really do it close to where the work needs to be done. So essentially moving processing to the workloads and where the workload is consumed or produced versus shipping all the data back into a central location.
Yeah, so physical proximity, physical location, that sort of thing is one of the key characteristics of Edge. Is there more to it?
Well, I mean, there's four real drivers, right? There's four real problems you're trying to solve by putting a workload like on premises, like out in the field, right? So you've got bandwidth, right? It's just producing a lot of data. Getting that back to the cloud is expensive. You got latency. You need to make decisions in sub 100 millisecond timeframes. Like you can't get it to the cloud, make the decision, and come back. You mentioned. Regulation, which is becoming more and more of an issue as people get more worried about privacy and more worried about data placement and data ownership. And last is connectivity, right? Like a lot of places don't have good connectivity. We actually see a lot of use cases like out in the ocean, right? And so they can't really use a cloud service as a solution because they have a really poor and expensive internet connection.
Yeah, I think the reason why we call it Edge is because there was a cloud. I mean, I think that's the first thing.
Right.
Because it used to be computer rooms, it used to be IoT, we used to call it different things. And I think the reason we are using the Edge term is because there is a cloud involved, and it's the edge of the cloud. And I think what Koroush said was really important. There was one point, which is that, yes, there are all these things that are driving, doing the computing and the storage, pushed out to near where it's consumed or where it's generated. But the key thing is there is a centralized level of control. Right, because that's what's different. Because otherwise, I would just be calling it a computer room, or calling it, a half rack thing in my retail store. I wouldn't call it the Edge. But
Perfect.
Because of the centralized control element that we like in the cloud, we would like to recreate with the Edge. I think that's what's interesting about the Edge.
I like that.
And I think that one of the characteristics, though, as well, is that it's more of a functional definition than it is a geographic definition necessarily, right? And Gina, you were talking a little bit about this as well, what like the applications that belong there and why Edge is a thing.
Yeah, I think the why Edge is a thing, it's why Edge is a different thing as well,
Yeah.
right? Because we have this ability because the hardware has improved so much that we can run all sorts of applications in various places, like the middle of the ocean, perhaps, or in rural Georgia, where my family's all from. And the other thing is we don't really know the users of things. So users on the Edge can be people, or it could be machines, it could be lights, it could be all sorts of things. But the work from the application has to get done in these places for all the reasons people said.
So it occurs to me that we've had Edge for a long time, sort of, and that we've had distributed IT elements, distributed applications, but they weren't IT in the conventional sense because they were very, very single-purpose, special-purpose devices. I mean, there have been AT&T long lines and all this kind of stuff for a long, long time. But what we talk about when we mean Edge is something that really is sort of a translation, like Roy was saying, of cloud into this remote, dispersed, distributed, disconnected world. Is that right?
Yeah, I think so. I think the way I look at it is, we've had stuff out in the field forever, right? And the difference is over the last 15 years, we've gotten very comfortable with cloud computing and not worrying about the hardware, not worrying even about some of the logical infrastructure, and just being able to quickly deploy apps out and spin them up and get what you need done. And I think that's what we're talking about when we're talking about edge, is basically extending some of that functionality of the cloud out clear to the edge, and you're running those workloads and having that same experience. We have customers who are, in the past, if they had 17,000 sites and they needed a new workload, they got 17,000 servers and shipped them to 17,000 locations. And now we're talking about putting actual infrastructure in place so they can spin up a new workload across 17,000 sites in 15, 20 minutes. And that's really, I think, what the promise of edge computing is.
Yeah, no, I mean, Scale's been there for a long time, starting in retail, and you've seen it, it's like a better VMware, well, better vSphere for distributed computing initially. And then now it's edge, because your capabilities have become more cloud-like than ever before, right?
Exactly.
So I think that makes a lot of sense. That evolution makes a lot of sense, absolutely. Yep.
And that's where I think I was going to, is that's the thing that's different, is we've got the hardware that can support it, but also applications are being built in such a way that you can spin them up on a dime. The user or the end user of that application could be anything. It can be a machine, it can be a person. The compute can all be done in one place and then sent back, or the data can be gathered in one place and sent back. Just however you want to write the application, whatever that use case is, to get data and change it into real knowledge is what's available. So that's kind of a different paradigm than having a place someplace out way in the boonies that there won't be an earthquake or a hurricane that can also preserve all your data, or having something in the back room of a convenience store so you can make sure they get the data.
Yeah, I think it's a good point. I mean, the edge is that continuum, as you point out, right? It's not centralized, but it's sort of spread everywhere. I think the key thing is the distributed computing element of it, or the distributed cloud element of it. That's what makes it really complex and difficult, right? Because what do you run, where, what do you store where, when, and how, that becomes a tricky thing to deal with.
So does it have to be part of the cloud? Does it have to be cloud connected, or could it be semi-connected or disconnected and still be edge?
I think it's definitional, right? Depends on what you define as the cloud. But I think the cloud-like capabilities of management, the cloud-like visibility, the on-demand nature, and the fungibility of the workloads, meaning that it's not a single purpose. I think those cloud elements do exist, right? I think those, can it run disconnected? Probably. Can it run disconnected forever? Probably not, because at some point, how do you manage control? I mean, it's permanently disconnected.
How do you even just deal with updates and that sort of thing, right?
Yeah, I mean, you could ship it on a USB drive, but that's not edge, right?
And I think that's one of the biggest challenges that I've heard from folks who are actually trying to deploy applications to the edge, is sort of the manageability and operational aspect of it, in that, you have these systems that probably don't have a data center around them, that probably don't have a person who can go and sit down and do a thing to them, that may be disconnected or sporadically connected, that may be exposed to challenging environmental conditions, and yet that have to work and have to reconnect. It reminds me of the Mars explorers and things like that. It has to kind of be autonomous, but also be connected, right?
Yeah, I mean, Opportunity is the extreme example of that, right? On Mars, you can't reach OPI, right? But probably less serious situations. I mean, the ocean, it docks at some point. On the plane, it lands at some point, and sometimes it gets reconnected. But it's not Mars yet. But
well, retail and restaurants can be a pretty harsh environmental condition too.
They can.
Sure. Yeah. Manufacturing floors. There's lots of places this stuff needs to run where, it's nothing like a data center.
Or like the military.
Oh yeah, that's true. Yeah.
Or disaster areas is another great idea for that.
Extreme environments where your devices can be stolen.
That's exactly right. Yeah, so, I mean, I'm just silent here because I'm agreeing, obviously, with all of the attributes you're mentioning. And I think if I was going to just summarize it, it is that cloud experience, but not in a centralized location. It's at the far edges of the world, in potentially even dangerous areas of the world that IT not only cannot reach, it's just physically impossible to reach it. Therefore, to have that those cloud attributes but also, cloud is in a concrete building that's pretty safe. Now, how do you protect and have that same level experience with bad connectivity, with geography that, and also security that it may not be there, right? So that's why it is actually a lot harder problem to solve.
It is.
Edge
It's
portion.
a much harder problem to solve. I mean, there is no truck roll sometimes, right?
Yeah.
It's a helicopter ride or worse. Right?
Yeah.
We have a customer that actually does that. Exactly.
A
We
helicopter
solved
ride,
that.
yeah.
Yeah. This was a customer that has oil rigs, right?
Yep.
And actually, every break fix is a helicopter ride, $5,000 for each break fix, and the solution is actually to employ the same thing as the cloud blueprint is. So as you were mentioning, the reason people love the cloud is they don't have to worry about the hardware.
Right.
Just get another one, spin it up, and it's that whole immutable strategy of bring it up, use it, and it goes away, and it's Amazon's problem or Google's problem to figure out how to deal with the hardware and refresh it and even patch it.
Right.
So once you move that to the edge, then how do you have that same experience?
Yeah, strategy is different.
Yeah, I think speaking of strategy, I think one of the things is there's just unlimited possibilities now that we're able to move the compute wherever the application needs and the workload needs to run. But I think probably one of the things that may hold back a little bit is just operations view, especially if we're old school operations and we did have to go, to the remote sites and spend stuff of ourselves. We might be holding back from what edge is, thinking it's just another, colo center. And how do you get a customer to say, no, we don't need to spin up one server in every store. We can actually do this a different way. It must be a light bulb that goes off.
Yeah, exactly.
It's interesting too because we tried to build this before virtualization and before cloud. And Gina, you and I both worked with EMC and with Dell and so on. Before virtualization, we were trying to deploy these things in the edge. I actually was defining an edge stack before virtualization that used, storage arrays and storage switches and servers, and it was just incredibly expensive and incredibly inflexible, and it required a person to go out there and build it. But then virtualization technology came in, and suddenly the hypervisor enables us to be much more flexible. And then, as Roy is saying, suddenly we've got all these cloud concepts. I think the most powerful concept is sort of the pets versus cattle. That edge is cattle. It has to be cattle. It has to be
Robust
something that you can just throw in a new one. It phones home. It configures itself, and it works. What is an example of what's not edge, though? Let's shift gears here. What don't we consider edge? Is this edge? Is my phone edge?
Yeah, so as the analyst, there are a lot of definitions, and some people do call the phone the device edge. I don't call it the device edge. That's not edge. That's the consumer. That's the UE. That's the end device. So I don't call that edge. Edge is infrastructure in the environment, whatever that environment happens to be. It could be CPE, it could be whatever it is, but it's not the end computing device, in my definition. But there are other analysts out there, or other people out there that talk about the edge as a device, or the device is the edge. And I think, it depends on how you want to look at it, but fundamentally, if you say edge is distributed computing, then okay, maybe that is an element of that, component of that, sure. But generally speaking, it's infrastructure people. Infrastructure is edge. Devices and consuming devices are not edge.
All right.
What if, though? What if you took a bunch of phones and repurposed them to be the end devices and be the edge device? Doesn't it really depend on the workload and the application?
It does the workload. And so if, for instance, if Stephen's phone now becomes a host for his watch, or his personal area network that whatever is attached to, I don't know where, but say they were, then you consider the phone maybe the edge computing platform is that. So that's true, Gina. That it does depend, right?
That's maybe the line, right?
Yeah, that may be the line.
And it's how you're using it, right?
Yeah.
It's a tough one too, because there are analysts who say it's either public cloud or maybe a private cloud, and the rest is edge.
Right.
And that waters down the definition so much that it makes it almost useless. And I'm still, I think, really struggling with it. I think.
Yeah, I think the best way to look at it is it's going to be use case dependent. But there are certain attributes of the computing environment in a distributed sense that you have to deal with, and the difficulty in provisioning, in reaching it, right? The robustness that you need. Right?
Yeah, I was at CES right after our conversation, and I was then looking at, as I was observing, I saw a washing machine, a brand new washing machine that has AI in it. It looks at your clothes and actually sees that don't mix the red with the whites, and it will just basically says, I'm not washing these clothes, right? You're going to ruin your clothes, right?
Wow.
So then I was thinking, okay, but that is pretty smart, but I don't consider that the edge because it's pretty fixed form and function, and it's so you could even say, just something that has a lot of electronics in it doesn't mean it's edge, right? And so that was one aspect. But then I saw this kiosk that used AI, looked at you and actually spoke with you, and it had a whole language model, and it was running on a robust PC with a graphics card, and it was actually getting assisted from the cloud. So if it didn't understand something, it would send the words, come back, but it would generate the AI locally, the images locally, but the language processing was off on the cloud, right? So I would say that was probably edge in my thought process.
Yeah.
So, kind of that tetheredness, but doing heavy processing to your language, to your definition, because it's just too much data, latency sensitive. And we have another customer that for manufacturing floors and safety, they put all these cameras to basically know who is going across the boundaries of unsafe zones. And they basically said, we'll do everything in the cloud. And then they realized that, and we use 5G, right? Everybody sold them 5G. 5G is a solution to every problem in the world. So then a day later, all their gigabytes ran out because of all the images that went back and forth. And then, they're like, we don't want to get $1,000 bill just for one of these locations. So just because of even commercial terms, they then now had to move all of that processing to the edge to even just make it a viable business a problem to solve. I mean, it could be done in the cloud, but it just doesn't make sense. So you got to move it to the edge. So those were a couple of examples that I thought makes a lot of sense. And then once you do that, once you move all of that processing and smarts to the edge, then the attributes of operationally keeping it up, dealing with all the common vulnerabilities that makes it a hacking point, all of those things that centralized cloud has, all of those attributes now needs to come to the edge and more, because you also don't have a concrete building around it protecting it.
That's right. Yep.
Yeah, and I think that it really does come down in a way to what Roy was saying, that it kind of depends. Consultant, analyst, it depends.
I know, it always
but it depends on what it depends on is how you're using it and what you're doing with it and what the purpose of it is. And so if I have a NUC sitting on my desk and I'm using it as a desktop, then that's not edge.
That's right.
But if I have a NUC sitting in a retail location with a couple other ones running scale computing, and hypervisors and workloads, well, then that is edge. And so it's not about the hardware. It's not about the location as much. It's about what the purpose is.
Correct.
And how it's being used. And it comes down, I think, to Scott, your points about those 4 characteristics of the edge. And to me, too, that the thing that's interesting there about the characteristics is that they define not only the definition of the edge, but also the requirements for solutions that are built to it. Things like intermittent connectivity or lower bandwidth or semi-autonomous operation or central manageability. All of these things demand the development of software and hardware that will meet those requirements that we never did have before, but now we do. Is that right?
Yeah, I think that's the point, actually, because, as architects, we know how to build something that will give the best performance to a workload. We know how to do that. So if our mind is kind of freed up to where that can happen and what types of devices we can use as an infrastructure, that frees you up to do so many innovative things with applications. And that's really where I think edge is as well.
And I think that's one of the really exciting things to me, is just at the very beginning of this and seeing what we're capable of now, and the ability to have real infrastructure out at the edge and spin up new workloads. And if you think about the cost of spinning up a new workload in the old model, it's monstrous. Versus the new model, it's so low. The amount of innovation we're going to see once people recognize the power of that is going to be really awesome. I'm super excited to see what people do with it.
One of the attributes that was mentioned is that you want to have a cloud-like experience, but at the edge, right? Now, the cloud, actually at ZPE, we've been building the cloud experience for cloud vendors by providing them the automation infrastructure, right? And that's why a cloud can spin up new workloads, can rebuild itself. Even the switches that connect all the compute together, you want to be able to, as was mentioned, rebuild everything, treat the infrastructure like cattle. How do you do that? The way you do that is, the blueprint that we learned by watching the hyperscalers is that they have an out-of-band infrastructure that can destroy everything and rebuild it, right? Because you don't want to cut your own legs off by, hey, I'm going to format my disk and now I'm dead, right? So this control plane, as as people call it, or a second ring, as we call it, and our customers call it a second ring, where they get an independent network to be able to manage and operate their primary network, where you can buy any switch, any compute, and even 5G connectivity, whatever connectivity. But then you have a parallel infrastructure that doesn't get damaged if the original one gets damaged, and this one can rebuild the original one. So from the deployments that we have at the edge, we have several hundred. That is actually the blueprint. If it's critical infrastructure at the edge, you would want to have a parallel infrastructure that automatically updates it, applies all of the patches. Even we had a customer in Ukraine that when the war happened, and like hours before the borders were about to be compromised, they wanted to decommission the entire edge, right? So it was about formatting before the internet lines get cut. So we were able to deploy scripts to decommission a data center that would take, let's say, 12 hours, but the lines were going to get cut within 10 minutes. So it was edgified automation using this parallel infrastructure. And so taking the blueprint that hyperscaler cloud has and applying it to the edge is the point of view that I have on how to make edge deployment successful.
Yeah, so I think, I would say that it's an exciting time to be at the edge because a lot of problems are not solved. A lot of problems that we solved in cloud computing with the concrete wrapping the data center, as we talked about, right? And then the concrete's gone. And so you have to recreate a lot of the controls that you used to have in the cloud now at the edge. And I think, we know that we've succeeded at the end of the day when there is no edge and it's one distributed computing architecture and the workloads decide where they run based on what the business intent and needs are, right? And that's when we know we've succeeded. But it's many, many years out, and there'll be tens and billions of dollars invested and hopefully made before all that's there. But yeah.
Yeah, it's a really fascinating space, and the fact that it repurposes a lot of technology that we've seen in, traditional technology of security and storage and virtualization and compute, and in cloud technology and networking, SD-WAN, all these other things. It really means that it's important and interesting to the community as well. And the folks that are following us with Gestalt IT and with Tech Field Day and following all the companies that are involved here. So that's why we're going to be having our first ever Edge Field Day event. We are launching this in February of 2023. And you may be watching this before Edge Field Day or after, but we're going to be live streaming and the presentations from companies like ZPE and Scale Computing. We're going to have wonderful delegates there like Roy and Gina to have this conversation. And we're going to be posting those on our YouTube channel as well. So if you're excited about this, if you're interested in this, please do check out Tech Field Day, check out the Gestalt IT, and of course, check out the links to our guests that we're going to be putting in the notes for this video. So thanks for watching. Thanks for being part of Edge Field Day. And thanks for being part of this conversation on Edge.